Hey guys, Mr. Wilson here. Today we're going to talk about the segment addition postulate. At the end of this video, you should be able to use the segment addition postulate to find missing segment lengths. Okay? Alright, so jump into it. The distance between any 2 points, a segment's length, is the absolute value of the difference of the corresponding numbers. Okay? So in other words, if I have a segment A, B, if I wanted to find the length of segment AB, then all I would do is I'd take the absolute value of A minus B, okay, whatever number they may be. Okay, that answer will give me the length. Absolute value, because distance cannot be negative. There's no way that distance can be negative. So let's do this first example. We want to find EF, okay, or the measure. Okay, length or measure. If they're asking us for a segment's measure, it's talking about the length. All right. So then we want to find EF. So in order to find EF, we can say, okay, well, the length of EF has to equal the absolute value of negative 4E minus F, 8. So negative 4 minus 8, well, that gives us negative 12. The absolute value of negative 12 is 12. Absolute value is going to be positive. Okay, again, notice how there's no symbol above the EF, and that just indicates that you're finding the measure of that segment, or the length of that segment. Okay, 2 segments with the same length are called congruent segments. Okay, and that's a symbol you should be used to or get used to. It's an equal sign with a tilde above it. Okay, means same number and length, or in shape. Okay, but congruent. Look at the markings on our diagram here. Markings shown on A and M and BM indicate that these 2 segments have the same length. Okay, you see that by the 1 dash there. Okay, therefore we can say that AM is congruent to BM. Because of this, we call the point M the midpoint, because it's in the middle, the point that is in the middle of the segment. Okay, so note when you get these markings, then that means they're congruent. Okay, all right. Just really quickly, just so I can expose you to this, if we had points, let's say DC, I could, in the same diagram, say that DM is congruent to CM by giving these 2 dashes, okay? And that would help you to know that CM is congruent to DM, but not to BM, okay? So those dashes would mark congruent segments. Okay, so now let's look at these examples towards the bottom. Examples towards the bottom. Got it? Okay. So it says find AB and BD. Okay, so asking us for AB here, BD here. Okay, and we can do that by just finding the difference between A and B. So for AB, that's going to be negative 8 minus negative 5, the absolute value of that. So that's negative 3, and has to be positive, positive 3. Okay, for BD, do the same thing here. BD is going to be negative 5 minus 0. So negative 5 minus 0 is negative 5. That is going to be 5. Okay, next question asks us which segment is 8 units long. Well, we can find that pretty easily, just because from 0 to negative 8, I can say, hey, AD is 8 units long. Okay, if we did that math, 0 minus negative 8 is 8, or negative 8 minus 0 is negative 8, and the absolute value will be 8. Alright. question 3 says, name two pairs of congruent segments. Okay, remember that congruent means same length. So give me two pairs of lines that have the same length. Okay, and bring that in to me tomorrow. Complete it. Alright, that'll be a way that I know you that not only did you watch it, but you put some thought into these notes. Okay, segment addition postulate, let's look at it. Okay, the segment addition postulate says if 3 points, and let's call them A, B, and C, are collinear, and B is between A and C, then we can say that AB plus BC equals AC. And that always sounds a little bit more confusing when we just say that whole thing out loud, but let me just draw a diagram for you really quick. We have we have 3 points on the same line, collinear points. We have AC and B is in between them. All this is saying is this segment AB plus this segment BC equals the whole line. Okay, part plus part equals whole. Okay, so with that in mind, let's answer these questions. It says find AB and CD. Well, a couple things we can use. They gave us this line, AD, and then they gave us a few measurements. They told us that BC was 20. They told us that AD is 54, and then they told us that BD is 36. So we just kind of use our reasoning here. If BD is 36 and BC is 20, segment addition postulate tells us this plus this has to equal the whole thing. So that must mean that this will be 16. Okay, so CD is 16. Okay, if this is 36 and the whole thing is 54, then 36 plus AB has to be 54. Okay, so we say 54 minus 36, well, that gives us 18. Okay, so we have that AB is 18. Found those two answers pretty quickly, and that was actually using the segment addition postulate. Question 2 says find AC. We should be able to do that pretty quickly. AC has to be 38. Okay. Alright. Next question. So, some of them are going to be straightforward like that, where we just have numbers, no algebra involved. Okay, but some of them we will have to put our algebra hats back on. Okay, and let's look at how to do that in this next problem. It says find the value of x. Show the equation you used. Well, here they tell us that dt is 10. Notice that that's the entire line. dt is the entire line. They tell us that ds is 2x minus 8 and st is 3x minus 12. So the equation that we can use, we can say ds plus st equals dt. Okay, ds plus st equals dt. Okay, and so now, since we know what all that is, 2x minus 8 plus 3x minus 12 equals 10. Just substituting all the values that we know or we're given. And so now here, this is just an algebraic equation that we can set up and solve because we already have it set up. So 2x minus 8 plus 3x minus 12 equals 10. Add our like terms together. 5x minus 20 equals 10. We'll add 20 to both sides. And so 5x equals 30. And then divide by 5. And that'll give us x equals 6. Always important to make sure that we're finding what the question's asking us to find. Okay, so in this case, they are just asking us to find x. We're good. Okay, now for number 2, it says find ds and st. Here it is. Okay, when they tell us to do that, they're actually asking us to find that length. Okay, so we're just going to plug this x value in and see what those lengths are. So 2 times 6 minus 8, 12 minus 8, give us 4. Okay, 3 times 6, 18 minus 12, st will give us 6. Okay, so some values that we have there, pretty good. Alright, hopefully that makes sense. Alright, let's set this problem up. Alright, it says for this final example, notice that we have a given. Now given, especially or given in geometry, is just information that they make sure that we know before we start. So some other given information, they told us that AC was 2x plus 1. They told us that CB is 3x minus 4. Those are given to us. But this one is given to us as well, just a little bit outside. C is the midpoint of AB. Why would they tell us that? Why do we need to know that? Well, if C is the midpoint of AB, what do we know? Well, we know that it has to cut that line in half. So these two segments have to be the same. And so, if these have to be the same, that will change how we set up our equation. Because with these other ones, we were looking at, okay, small plus something we don't know equals the big thing, small plus something we don't equals the big thing. Well, this one, we just know that these two are equal to each other. That's an equation. 2x plus 1, AC, is equal to 3x minus 4, BC. Okay, and now we can use that to find x, and then we could use that to find AB. Okay, do that and bring those in completed. Alright guys, hopefully you understand and can use the segment addition postulate. See ya.